Alright, so we have just gotten out of our little unit on like the polyalphabetic ciphers and monoalphabetic ciphers. We had our assignment last week for the sort of review before we step into this new section on modern computing. And the first thing we're going to talk about is binary. So binary is just a string of ones and zeros. It's the language of the computer. And you can see on this screen here, I have a conveniently placed chart that has all of this already typed out for you. This has all of your main alphabet as well as some characters, periods, exclamation point, question mark, parentheses, and a dash. So this gives you these are only five numbers long. Normally they can go up to eight. But this has all of the stuff that we will use for the intents and purposes of this class. And basically, I'll just kind of go through what this conversion is doing. So we have this big old list. And if you look at it, you have A, the string, and we have a colon that corresponds with this. And we have our binary number for it, which is 00000 all the way across. We have the comma and then the next item in this list. So this is a pain to type out. Just go ahead and trust me on that. I will make sure that you have these charts and these functions available to you. But I'm just going to go through what this binary converter and the text converter will do, and like what this text is saying, because we've essentially done this sort of thing before, so I wanted to type it out for you beforehand. So we have our binary converter. Again, here's this. We go through. We have our binary string. That's what this is short for. And we have our open string here. So we have a for loop inside this text string that we're given. Basically, what it does is it takes this and then just adds what position it is. If you remember this square bracket function, if our first letter in the text string was A, then it would go find A and then look over here and see what the number is and then add it, and then it just returns that. This does a little bit different because a binary is grouped up differently than just letters are. So it'll go through there, and then like I was going through, this will convert the text from the binary. We have this reverse binary function. This is a little more complicated. I'll probably make a video at a later date walking through how I made this function. But for right now, just be happy you have this function. Uh,
Marcus?
yeah, what's up?
Um, do we need to convert the text to upper, or will we have to put it in as upper text when we input it?
Yeah, it's a good question. So yeah, it will have to be upper. It is case sensitive, so you can see these are all uppercase.
Okay.
If you went through and you made this thing all lowercase letters, then it would be fine lowercase, but you can't have upper and lowercase. You can do special characters except for space. Um, but yeah, like if we go through this binary converter, convert, and then we'll give our word here. We can just say like, I don't know, computer, and because it's lowercase, it doesn't really know what to do here. Um, but you'd have to come in here and do the uppercase of that, and then it would go through. But that is not really what we're gonna. I'll link this class REPL in the Discord later if you want to have access to this. If you want, you can remake it. That's fine by me. But we're gonna go through the XOR function, which was on the review sheet that I gave and created last week. I'm just going to quickly walk through what the XOR function does in like an abstract sort of thinking about it way, and then I'm going to walk you guys through the code. So basically, what XOR is, its symbol is like a circle with a plus through it. And basically, it's how you will essentially add binary. If you remember, binary is just zeros and ones. So this function accounts for that being, what's 0 plus 0, what's 1 plus 0, and what's 1 plus 1, which is 0 in the XOR function. So if we did an XOR by hand, we'll just say we have two bits right here. We'll make that a command just so it doesn't screw up. So we have 11011 and 10010. I think the easiest way is just like you would do addition, is to line them up, and that way it's just a little easier to look at them because you're going to go through row by row. Or if you look here, you're going to add this row, these two ones, then this one 0, 0, 0. And basically, by hand, it's just like addition. 1 plus 1 is 0. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 0. 1 plus 0 is 1. So basically, if there's a 1 and a 0, the resultant is a 1. If there's two zeros or there's two ones, the resultant is a 0. So that was very easy, but we're going to go through here and make one a function of that in Python for us, and then this will go through for our first cipher. Your assignment will be to go through and make the XOR cipher, which is very simple, and you'll have all the stuff here. You just got to put it together. So we're going to go here, say define XOR function. Remember parentheses, and we're going to have our two variables. We're going to have our binary, we'll just call it bin1 and bin2. These are our two different strings of binary. They can be any length. It does not have to be a significant amount for this one, I'm pretty sure. I actually haven't tested that, but we'll do that in a little bit. Do a little bit of troubleshooting on the go. So if we're going to first thing we're going to do is our bin1. We're going to essentially text clean it right now. If you remember, whenever we do this with a English alphabet, we would have to take out the spaces. We'd have to uppercase everything. And basically, this is sort of similar for binary, but it's not quite the same. All we're going to do is replace spaces with nothing. This looks like a useless thing, but right here in between these two quotation marks, there is a space, because whenever you are having multiple different sets of binary, like for example, this is A. If we wanted to do B, we wouldn't just add on like that. We'd have our A, then we'd have our B, and then we'd have our C, and then we'd have our D. So they would just have a space in between, but we don't want that because that would confuse the program. So this, all it does is remove that space. We are going to do the exact same thing for our second binary here. We're going to take our replace, open quotation marks with a space in it, and then another empty quotation marks. So basically, once we have this, we're now ready to try and do our XOR function here. What we're going to have here is we're going to say our product from doing this function is format. This is just a formatting function. You can look this up later, but it's just going to help us. We're going to say int, integer, because if you look at all of these, there are no decimals, and that would make this an integer value. Integer, and then binary, bin1, and then we are gonna just say comma 2, and then we have our caret here, integer, binary, or bin2 rather, the same 2. And then I had on my code B here. This B is just for the format function, this right here, but it doesn't really matter. You won't have to replicate this or know why. You can look it up if you want. I'll link the format function Python, how that works in the Discord as well if it interests you. So now that's the meat of our function there, and actually the caret there is the XOR function in Python. So if we did, for example, well, I guess we'd have to print this. We have something there. Our caret is XOR. We can do something like that. And if you print it, you can see it does the XOR for that right there. So basically, that's what this integer binary thing is with all this stuff. Essentially, we're just trying to get this XOR function right here. From this point on, we're going to just return. We are done here. We already have our product. I'm going to say our product.zfill. This is just another formatting thing. Max. And this is just finding the max of them. Length, again, if you remember this is the length of the binary. Bin1, and then comma, the length of the bin2. And that's all for that. This is basically just so we get the right number of our result comes out with this product of the same length of binary and also has this readable function. So let's go ahead and try this function out right here. XOR function, and then we're going to just give it a guess here. You're going to want to have your binary in parentheses, I think. Hang on, I don't actually remember. But we'll just try that and see if it works. Yes, it does work. I'm just going to get rid of this function right here. That was just a little confusing. Yes, so there it is. I have another copy of it down here. But this is just the XOR function, a very simple function, and it will go along with the cipher that we're doing, which is the primary objective of the cipher, is using XOR. I believe it is called the XOR cipher in layman's terms. And then you will just use this converter from 2 binary and 2 text in order to incorporate cryptography for it. So before I go off into letting you guys go on your own, I'll kind of describe what this cipher is doing. It's very, very similar to something like a monoalphabetic cipher that we were doing. Like, think about a multiplicative cipher. We're going to say our plain text is we'll just go one step at a time. We're going to say our plain text first letter is T. That would mean that our binary for that is 1111011. I just looked at that up here in this table. And then we're going to say the key first value is P, which is 01111. The cipher resultant from that would be this these 2 binary strings XORed together. So you get 1 XOR 0 is 1, 0 XOR 1 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0, 1 XOR 1 is 0. So this would be the resulting binary 11100. And if you highlight this, Rep will be kind enough to tell you that this is a question mark in ciphered language. So this is where ciphered stuff will start to have special characters. We haven't seen that before. Every time it's just been another letter in the alphabet. But that's the objective of this XOR function, is to make it even more complex. This is slightly more difficult to break into than a monoalphabetic because there are an additional 6 terms here among these guys right here. But it should be fairly simple. I will probably make some video if it's necessary to go over how to do this stuff. And if there are any questions, feel free to DM me.